I'd like to now invite Tony Paterra to talk about how we are enhancing ZPA to reduce some of the lateral propagation risk as well as the attack surface with ZPA. Thanks.
Thank you, Amit. Continuing on this theme of reducing business risk, we're going to talk about the areas that we're helping prevent lateral spread. There's 3 specific areas that we're investing in multiple features going into each one of these areas. First is segmentation. Second is third-party users. And last, compromised users. As Amit commented on, at Zscaler, and particularly inside of ZPA, we believe in taking users off of the network. The network was designed to provide connectivity, not security. This creates many opportunities for lateral spread. First, 2 of the things that we're bringing into the Zscaler for Users portfolio is visibility into your existing attack surface, as well as visibility into your existing usage of Zscaler Private Access. These will be incorporated into our exec reporting suite, where they'll show up in the quarterly business review PowerPoints that you can download out of the ZPA Console. And also, if you would like an up-to-the-minute view of your external attack surface, we're including this in our Exec Insights iOS app for visibility into places where you have public exposure and an attack surface that can be exploited. But then the real work starts. Segmentation. Segmentation is a 4-letter word that's lasted for well over 2 decades inside of security. Every user starts with ZPA by going to what we refer to as discovery mode. They need to understand the applications they have, and they need to understand how their users are accessing them. Then they start writing their first user-to-application segmentation policies using a bunch of policy contexts that help shrink the attack surface out of the gate. But there's a long tail of things that need to be addressed. And so there's 2 areas that we're excited to bring inside of ZPA in the near future. First, risk-based policies, and we'll walk through some detail on that. Second, we actually are introducing a new AI-powered segmentation engine that we've been prototyping and testing with many of you in the audience today. With our AI-based segmentation engine, we're taking context from your authentication repositories to understand business context. Who is the user? What department do they work in? We're using visibility from the client to bring in things like client process using Client Connector. And then lastly, we're using the access policies out of ZPA to help understand the application. Now, at the end of the day, this is to help reduce and shrink that attack surface. This example behind us is anonymized from a real customer environment, where in this particular customer environment, they were using discovery mode like many people do as their starting point for ZPA. When we turned on our AI engine, what we found was there was 2 specific types of applications that were used by a certain set of departments. As you'll notice, this is a planning and budgeting application, where the user groups were finance, audit and control, and the CEO's office. Because we had the config data from ZPA combined with the actual usage data and the recommendations from the engine, we realized that overall, 20,000 users had access. Viewed from a security context or a defender's perspective, that's 20,000 points of possible lateral spread to applications that sound rather important. So what we were able to do is recommend that those 20,000 users are shrunk down just to 50 users that actually need access. That's a 99% reduction in the attack surface, and we're bringing that straight into the ZPA console to help provide visibility there. To give one level deeper of context, strategically, we also have visibility into the client process that's initiating that connection. The other piece here, if that's an SAP application, you can have SAP logon.exe as context that we actually get to cluster on more. We're very excited at the power this brings to help advance overall attack surface reduction to help limit lateral spread. Amit touched on this briefly, but the inclusion of risk as policy context is also very helpful. By combining all of the telemetry we get out of ZIA with ZPA, you can start to have a picture of who your risky users are and what private applications they shouldn't be allowed to touch or should be, have extra compensating controls when they actually do access them. When you have views on how much people are clicking on credfish links or how much folks are visiting newly registered domains, you can build up a strong profile to understand how risky that user is. And you can start to introduce compensating controls that we recently integrated inside of ZPA, namely application protection for inline inspections, as well as integrated deception. So let's see how this will work. First, you can identify your low-risk users. We can say everybody with a score below 85, we'll call you safe, or reasonably safe. Well, if it's a crown jewel application, you probably actually want to be extra careful because low-risk people can still be compromised. So why don't you ensure that if these low-risk users are touching this application, one, they're using a safe device with your EDR running. Two, make sure that traffic is protected and inspected using our inline inspection capabilities. We think this will materially move the needle forward in reducing the risk of lateral spread. Third-party users have their own set of challenges, though. By connecting them to the network, they're allowed very broad access when their jobs usually don't require it. Next, you have limited visibility and control of the machines they're using. Said differently, you probably can't install an agent, so you give up a lot of visibility as the person enabling them to do their job. And then lastly, lifecycle management. This is very ephemeral usage. Come in, get your job done, offboard. But you need to revoke that access so you don't have stale access sitting around. Earlier this year, we significantly upgraded our agentless capabilities inside of ZPA with the inclusion of privileged remote access to provide very granular application access, specifically using RDP and SSH, just to a particular set of applications. We've removed the broad access problem with doing that. Next, we're going to be adding time-based access so that you can say, hey, these people, they can do their job 9 to 5 for a given 2-week period and then roll them off. We think that helps deal with the lifecycle management problem of third-party users as well. Even with the most perfectly managed attack surface, users can and will be compromised. So what happens then? For us, we have a suite of capabilities that we introduced inside of ZPA over the last 6 to 12 months that we're doubling down on. Application protection helps protect vulnerable applications. Deception, we're extending it not just from the application layer, but we're also extending it out to the endpoint. And we're going to walk through a little bit of how that helps understand when a user is compromised and contain the lateral spread event. First, as many of us obviously remember, not too long ago, Log4j. With our application protection capabilities, one of the things that we're adding into app protection is the ability to have our Threat Lab Z team push Zscaler signatures into those devices. That'll help get ahead of day zero attacks, where we can provide a little bit of help and put additional controls in place for you. Next, application deception has now been fully integrated across the Zscaler platform. So, protecting against vulnerable applications. That's kind of a noisy thing to move laterally in an environment. It's going to set off some alarms somewhere. Why not just live off the land and use what you already have access to? So one of the things we're doing with deception is integrating it directly into client connector. So there's no separate agent. We just provide one agent. Now, what we can do, though, is provide lures and honey tokens out on those endpoints, which help understand scenarios like the following. This is an open source threat tool that effectively looks for stale access tokens and sees what a user has access to move laterally through an environment. In this scenario, what they're doing is basically taking a leftover cookie that had access credentials to a private SAP instance. Now, what's really happening here, this is not a real cookie. This is not a real application. This is just showing up an SAP instance hosted on Zscaler's decoy cloud. And so what you find is that you have an attacker. What do I have access to? go and visit the application. Behind the scenes, this is what your SOC team gets to see. They get extremely high fidelity indicators with very detailed granular information. There's an attempted web login. This is not normal user behavior. This is very hard to spot using behavioral indicators. And so what we think this provides is a way to not try to secure the network, but understand when the user is compromised, not provide a flood of events at your SOC team, but give them very actionable intelligence. And then lastly, contain the blast radius. This is directly integrated into ZPA, so if an attacker trips over this tripwire, you can cut off access and immediately stop the lateral spread event. This is not the only things we're working on, though. Many of you in the audience have helped contribute to some of the key features we're working on. A number of you, in a high-quality problem for us to have, if someone is a Zscaler customer, moving between ZPA tenants is a challenge. That's something that we're on the roadmap going to fix shortly. Second, reauthentication notifications with ZPA. We're working hard at giving a better end-user experience for reauthentication notifications. Incident response tools. They like to have server-to-client relationships. We're also working on that as well. So thank you very much for partnering with us to help us build a more successful product in your environment. With that, I'm going to welcome Amit back to the stage to share more exciting enhancements.